Okay, now we're going to look at the global carbon cycle. Now we've covered this a little bit. We've talked about how carbon moves through the different spheres of Earth or moves through the different systems of Earth, whether it's in the atmosphere or the oceans or wrapped up in the biomass, mainly trees. But now we want to look at some actual numbers so we can track how much carbon is being shifted from one place to another. All right, I'm going to point out a couple things on this chart because there's a lot going on in this chart. Let's start with the reservoirs, the carbon reservoirs, okay? And if you see in white, you see these numbers in parentheses, like atmosphere up here. That's showing you that the atmosphere has 800 gigatons of carbon. So as far as the amount, the gigatons, don't worry too much about that. It's been simplified. The numbers have been simplified, so you can still figure out relatively where most of it is. So like if you look at the atmosphere with the 800, and then you look down at the soil is storing 2,300, quite a bit more than the atmosphere. The fossil pool is 10,000. So again, a lot of carbon's locked up in the rock, in fossil fuels, and in soil. Some in the atmosphere up here. If we look at the ocean, especially the deep ocean down here, there's a huge, huge amount. Now, the deep ocean still doesn't have as much carbon as the entire Earth, entire solid rocky Earth. But these numbers over here with soil and fossil pool are just talking about one part of the solid Earth. Okay. So anyways, deep ocean. Again, quite a bit more carbon stored in the deep ocean than in the atmosphere. And then we have another one down here, reactive sediments. This is all the silt and mud and sediment that is accumulated on the bottom of the ocean floor. Ocean surface right here shows that there's 1,000 gigatons. The only other one that we're missing looks like plant biomass. Okay, so I just highlighted all of the reservoirs. These are the storage areas of carbon in the Earth systems. So the carbon primarily is locked up in those places. But the next thing we're going to go over is how much carbon moves between systems from year to year. Okay, so we've talked about the carbon reservoirs where it's stored. Now look at some processes which we've talked about of how carbon is transferred. So we've talked about photosynthesis before, but we haven't put a number to it. So we know that photosynthesis pulls in carbon from the atmosphere into trees, and we get a number here of 120. And then you also see this plus 3. We'll come back to that plus 3 in just a moment. But 120 gigatons of carbon is going to be pulled out of the atmosphere and put into plant material and into soil through this process of photosynthesis. So the 120. Now, plants also give off carbon dioxide in respiration, just like animals and humans do. And that is going to be 60. Plus, microbes in the ground also go through respiration, and they're going to give off 60. Now, what you notice is 120 going in and 60 plus 60, which is 120 going out. So far that's even. That's equal. This plus 3 right here is from humans. That's why it's in red. So because of the plants and stuff that we grow, the extra biomass, things of that nature, through our processes, we actually take an extra 3 gigatons out of the atmosphere. So that's good. That's actually pulling carbon out of the atmosphere. However, the last thing you're going to notice here in red is the amount of carbon that we put back into the atmosphere, fossil fuels, cement, and land use, which is 9 gigatons. So if you notice, the 120 in cancels out with the 120 going out. We've got plus 3 that we're responsible for going in, but 9 going out. So if you take 9 minus 3, we get a net total so far of 6. So in this process, we're responsible for 6 gigatons of carbon going into the atmosphere. That's extra carbon going into the atmosphere. Okay, so we saw that there was a net gain of 6 gigatons of carbon over on this side. And remember that 6 gigatons comes from fossil fuels. Okay? That is our factories, our cars, land use, and other factors. Usually we think of factories and cars putting extra carbon in the form of CO2 in the atmosphere. Now there's something else. We haven't covered the oceans. So, oceans here, we've got natural process here of carbon dioxide dissolving into the ocean water. 90 gigatons dissolves in. Also, carbon dioxide is used by plankton for photosynthesis. There's an extra 2 gigatons, and it's in red. That means that that was from our contribution. So we've done things to oceans that enhance the amount of plankton that actually go through photosynthesis. So that's what that plus 2 is. Now, as far as CO2 that comes out of the ocean, that is 90 gigatons. And that's from respiration, decomposition, similar to the stuff that we see on land. Plankton, algae are respiring just like the animals are, and they're putting CO2 into the ocean water. That ocean water loses some of its gases just naturally. So you get 90 here, but 92 coming in. So if you notice, there's actually a net uptake of 2 gigatons into the ocean. Okay, 92 coming in over here, and 90 going out. So the oceans actually take in more carbon dioxide and carbon than they store, or than they give off, I'm sorry. So now instead of 6 total gigatons of carbon that we're contributing every year, we can take away 2 from here, and that gives us a total of 4 gigatons of carbon that are going back into the atmosphere. So this is the actual math. This is the actual studies, scientific studies that have been done over and over and over. And each year this changes, but it never gets lower. Each year it just gets higher. The amount of CO2 that we're putting in will continually, at least for now, go up. And right now it's approximately 4 gigatons extra per year.